This is the video for the butane gas lab that we will be doing on Thursday. So what you need to get started is a tub filled with water, a graduated cylinder, a butane lighter, and a thermometer. A couple of pieces of information that you're going to need to get before you start the lab is you need to have the barometric pressure of the room. So in the front of the room on the chalkboard is a barometer that measures the atmospheric pressure in the room for that day or that hour. Now it fluctuates throughout the day, so it's not something that you can get later in the day and come back and get. You need to get it at the moment we're doing the lab. So either before we start or after you're done with the lab, head up to the front of the room and write down the barometric pressure. That is used as the total pressure when we do our displacement of water calculation. The second thing you're going to need to do is you need to take the temperature of the water. So whatever water is in the bucket that you are using, you need to take the temperature and write that down. The vapor pressure of water number that is normally given to us in the problem is a number that is dependent on the temperature. The warmer the temperature, the more molecules that are going to evaporate into your graduated cylinder. So I'm going to go ahead and write that number down. And then also what you need to do is you need to take the mass of your butane lighter before you do anything. Make sure the lighter is completely dried off. We don't want the mass of any added water droplets on here. So before I do anything, I'm going to put it into my scale and take that mass as well. Okay? So for your setup, what you need to do is instead of using a eudiometer tube, we are going to use a graduated cylinder to collect our gas. It's just a lot harder to get the butane lighter inside the eudiometer tube to collect the gas. So this has a wider mouth on it, so it works a little bit better. So you want to dip your graduated cylinder into the water and get all of the air bubbles out. You don't want any air bubbles in here that is not butane. So I'm just going to kind of shimmy it around and try to get every last, there's the last one, got out of there. Then I'm going to tip it upside down just a little bit, but still there's no air in here. It is filled with water. What I'm going to do under the water is I'm going to take my butane lighter and I'm not going to ignite it, so I'm not going to use the sparking mechanism. All I'm going to do is I'm just going to push the black paddle down. When I push the black paddle down, what's happening is the liquid butane is being released as a gas, and we're going to try to collect that gas. Now, don't do that before you actually have it under the water like I did, because now I lost some of my mass. I would need to dry this off, remass it, and write that down. But I'm just showing you what to do. You're just pushing this black paddle down. So what I'm going to do is take my lighter under the water, line it up so it's inside my graduated cylinder, and I'm just pushing that black paddle down, and butane is escaping out of the lighter. And so what's happening is gas by displacement of water, as you can see in the video right here, I'm afraid to let go of it, there are bubbles coming up. That's butane gas. And so right now what we're doing is we're collecting gas by displacement of water. We're replacing the water with the butane gas. So at the top of the graduated cylinder, I have a mixture of gases. I have the butane gas, and I also have the water molecules that are evaporating as I'm bubbling this through. What I'm going to do is I'm going to continue to do this until I have about 90 to 95 milliliters of gas. So it's not going to take too long. It's going kind of fast. Right now, if I looked at it, I'm already at 40 milliliters of gas. So you just kind of have to hang on to it until you get to 90 to 95 milliliters of gas. So if we're thinking about the calculation, step one of gas collection by displacement of water is always to take the total pressure, which you're going to get from the barometer, convert it to ATMs, and then you're going to subtract the vapor pressure of water. Well, where do we get that vapor pressure of water from? You have the temperature of water, and it's really easy just to Google what is the vapor pressure of water at 32 degrees Celsius. Check your units when you do that. It might be in ATMs, it might be in torr, it might be in millimeters of mercury. You will need to convert it to ATMs, but then you can just use those two numbers and subtract them to get your pressure of butane. Okay, so I'm getting closer to the 90 to 95 range. All the while, I'm making sure that my graduated cylinder stays underwater so I'm not getting any extra air bubbles. Okay, so I've completed that. This is where it's helpful to have a lab partner. I'm just going to kind of lean that and hope that that doesn't fall off. What you want to do is you want to dry your butane lighter completely dry. Any water droplets is going to add mass. Okay, and you know that's going to be the analysis question. What happens if the butane lighter is wet? How is that going to affect your final molar mass? Okay, so dried off. I'm going to put it back on my scale, mass it, write that number down. So obviously the difference between those two masses is the mass of the gas. In a molar mass calculation, the units are grams on top divided by moles. What I just did was subtracting those two numbers as I have my grams. I have the mass of the butane gas that is in my graduated cylinder. Now, of all the numbers in PV equals nRT that I'm missing, I need a volume of gas. So I can't just pull this out because then I'm going to lose what volume of gas I have. So I'm going to keep it upside down, and I'm going to see if I can kind of show you this. And what I need to do is I need to equalize the pressure. So what that means is my line where my gas is needs to line up with my water level. So I'm going to move this up and down. Be careful not to pull it all the way out and fill the thing with air. You'd have to start over. I'm going to line it up to so my two water levels are even. If you notice that volume of gas changes as I'm moving this up and down, that's because of the pressure. Water has a lot of pressure to it. We need to equalize it. So once they're lined up, then I'm going to read my volume and write that down. Okay? So I'm going to solve for pressure using my gas displacement of water, subtract my total and my pressure of water. The volume for PV comes from this, equals N, I'm solving for. R is regular R, and T is the temperature of the water. So I have my grams for my mass, and my bottom number, my denominator per mole, comes from my PV equals nRT. So that is that. We are going to do 3 trials and see how our numbers differ. And then we're going to compare it to the actual molar mass of butane. And now that you had a day of organic, you know what butane is.